Okay, question 4 deals with momentum and conservation of linear momentum. It should be noted that we are dealing with only linear momentum. Right, question 4 reads, a bullet moves east at a velocity 480 meters per second. The best that anyone can do for themselves, as you read, is to highlight these important values. So a bullet moves at a velocity of 450 meters per second. It hits a wooden block. This is our wooden block that is fixed to the floor. So the wooden block is not moving. The bullet takes 0.01 seconds to move through the stationary block and emerges from the block at a velocity of 80 meters per second towards the east. And then they say to us, ignore air resistance. Now, the moment they say we must ignore air resistance, it means we are dealing with an isolated system. Now, what is an isolated system in physics? Right, this is a system in which the external net force is equals to 0. That means the only forces that are involved in this collision or explosion are the internal forces. So on question 4.1, they ask to explain what is meant by an isolated in physics. So 4.1, one is going to say a system on which so it's a system on which the net external force is 0. All right, then number 4.2, they ask you to calculate the mass of the bullet. Now they've just said the magnitude of the momentum of the bullet before it enters the block is 24 kg meters per second. So we can use that information to actually calculate its mass by saying momentum is equals to mass times velocity. So we come in and we put our 24 equals to the mass, which we don't know, but we do know that the velocity is 480 meters per second. Now we need to bring in our calculator. Therefore, the mass of this object is going to be 24 over 480, which is going to give us 0.05 kgs. So the mass is 0.05 kgs. All right. Now we go to, that was 4.2.1, then we go to 4.2.2. They say calculate the average net force that is exerted by the wooden block on the bullet. Now to get this one, we need to realize that according to Newton's second law, F net is equal to change in momentum over change in time. Now we know the time it takes to go through. We just need to calculate the change in momentum for the bullet. That will be V final minus V initial. At this point, you can indicate that you're taking east as positive, or it depends on which one you'd want to take as positive, all over the change in time. The mass of the bullet is 0.05. Final velocity is 80 minus initial velocity 480, all over the change in time, which we were given as 0.01 second. Right. We bring in our calculator to help us with our calculation. So let's bring in our calculator. Always try, if possible, to use brackets and fractions where possible. So 0.05, 80 minus 480, close that bracket, and then we put 0.01, and we get our answer, which is going to be minus 2000. So we write our answer here, minus 2000. Remember, the units are going to be in newtons. Now the minus 2000, you cannot leave it like this. That's where you now need to tell us that therefore the net force is actually 2000 newtons to the left. Right, that solves this question.